There's a big difference between a calorie and a calorie. They're kind of the same unit, but they're kind of not. What's the difference between a calorie and a calorie? Well, that's what we're aiming to find out in today's video, along with a lot of other things about food and nutrition. Let's get started. One calorie is defined as the amount of energy that it takes to heat 1 milliliter of water by 1 degree Celsius. So for example, if you burn something and that releases 300 calories of energy, that'll heat 300 milliliters of water by 1 degree Celsius, or 1 milliliter of water by 300 degrees Celsius, or any combination of them. However, 2,000 calories is not enough to fuel a person for a day. That's where the difference between calories and calories comes in. Now, if you're just listening and you're not watching, you'd better pay attention now, because it really makes a difference how it's spelled. 1 calorie with a capital C is actually 1,000 calories without a capital C. In countries other than the United States, some of them actually on nutrition labels put kcal, K-C-A-L, which means 1,000 calories. 1,000 lowercase calories, and that is the unit of calories that we use for our nutrition information. However, we just call them calories with a capital C. A Snickers bar does not contain 300 calories as in lowercase c, enough to heat 300 milliliters of water by 1 degree Celsius. No, it contains 300 calories as in it's enough to heat 300,000 milliliters of water by 1 degree Celsius. That's a lot more energy than with a lowercase c calorie. Now, for this video, I made a calorimeter. I'm going to show you how to do that in just a minute. But first, we have to define where we get our energy. We need a lot of energy to live. Just our heart beating, that takes quite a considerable amount of energy. That's why we have to eat food. Carbohydrates and protein both provide 4 calories per gram. That's calories with a capital C. Fat provides 9 capital C calories per gram. However, fat is more difficult for our body to turn into energy, and so that's why it's not necessarily the best thing. We'll get into why that is a little bit later. For now though, we're just going to stick with how does our body use the chemicals that it gets from food to turn into literal energy. Our body can take carbohydrates, proteins, and fat and make them into ATP, which our body uses for energy. Our body always goes for carbohydrates first because that's the closest to ATP already. Carbohydrates usually come in the form of glucose, which is really easily turned into ATP by the body. If you want to learn more about our body's reaction with ATP, go ahead and check out my video about that right here. But how does our body get energy from fats, carbohydrates, and protein? Basically, our stomach acids break those things down. There's some exchanging of electrons and energy as heat is produced. When the electron donors, which are the proteins, the fats, and the carbohydrates, when they give their electrons to oxygen, that releases energy as heat. However, making ATP requires heat to happen. However, we have a reaction that's making heat. It's the transfer of electrons from the electron donors to the electron acceptors, and so that heat can be used to make ATP for our body to use. The electron donating reaction is actually very similar to what happens when things burn, but sorry, there's no stuff burning inside of us. The 3 different chemicals, proteins, fats, and carbohydrates, are synthesized at different times because they're more and less difficult to synthesize into heat into ATP. Carbohydrates, as I said earlier, are really easy to turn into ATP, and so they are always used first. Protein is used next. The molecules are a little tougher and the strings of proteins are a little tougher, so they're harder to break down. That's why they aren't used right away. Fats have the most energy, but fats are also always last. Why is this? Fats are always used last because basically they float away from the things that can turn chemicals into energy. They're basically less dense than carbohydrates and proteins, and so they'll float away from the cells that are turning them into other things. And that's how our body turns fats, carbohydrates, and protein into energy that we can use to move around. We get this energy from our food. How do we determine how many calories are in something? We use a device called a calorimeter, and you can make one pretty easily. I made one for this video, and you could probably make one too. That's why I'm going to show you how right now. let's go. To make a homemade calorimeter, you're going to need a can that can be turned into a tube and house another can inside of it. I found the standard sized soda can fit inside a Campbell's Chunky can, but I needed the Campbell's Chunky can to be taller, so I used 2 of them. You need about 1.5 feet of stiff wire, a metric tape measure. You don't technically need a drill, but it might be helpful. If you plan on using a drill, you need a drill bit that's wider than your stiff wire. You're also going to need a hacksaw. A pair of scissors will also come in handy. The first thing you're going to do is cut off the top of the soda can. It might make some horrible noises, and you kind of just have to get over it. Once you get a slice going, you can use scissors and cut around the rest of the way. The top does not need to be perfectly straight. If it's a little wiggly, that's fine. Go ahead and pull the top off of the can. There was still a little bit of moisture inside of my can, so I wiped it out. If there are any shards that are sticking off of the top of your soda can, go ahead and cut those off. Then use a piece of sandpaper and sand it down so it's not sharp. At this point, you can either use a pencil or a drill to poke holes opposite each other in the can. Poke 2 holes opposite each other in the top of the can, and then 2 holes perpendicular to those that are also opposite each other. What these are going to be used for is sticking your wire through them in an X pattern so that they are suspended inside of the other cans. Go ahead and set that can aside, and now we're going to work with the larger cans. The first thing we're going to do is cut the top and bottom off of one of the cans. I'm going to do a little video work and do some fast forwarding right here. If you have a Dremel tool or similar with a cutoff wheel, you can go ahead and use that. It will be a lot faster. Once you get the top cut off, go ahead and smooth it out with some sandpaper like we did on the other one. Repeat this process on the bottom of this can as well as the bottom of the other can. Do not cut the top off of one of the cans. Stack the 2 cans together and then tape them together with some heat-resistant tape. Duct tape works, but you might have to replace it after a couple uses of the calorimeter, as it tends to melt. Next, grab your stiff wire and a pair of wire cutters or scissors. Figure out how wide your widest cans are and add about 1/4 inch to that. Cut 2 lengths that are that size. You're going to stick the wire through opposite holes on the smaller can in an X pattern. Next, you can set the smaller can with the X wires in the top of the larger tube. This next step isn't technically necessary, but it makes it more accurate with national and international standards. Measure in centimeters the distance from the bottom of the top can to the bottom of the bottom can. I got about 12 centimeters. When you burn a piece of food, it needs to be about 4 centimeters under your top can, and so in this case, I need to make my piece of wire that's going to hold the food 8 centimeters long. Using the remaining portion of your stiff wire, measure 8 centimeters. Then bend it at a 90-degree angle at that 8 centimeter mark. Then you're going to bend the wire around so that your wire will stick straight up. That's all for the making of your calorimeter. Next, we need to figure out how to use it. Let's go. To use our calorimeter, we're going to need a couple more things. First, we're going to need something to light our food on fire. We're also going to need a scale to measure the weight of our food. You will also need a meat thermometer. Thirdly, you'll need a measuring cup and some water. I'm using a walnut today, and so I'm going to set that on fire, but first I'm going to measure how heavy it is. I weighed the walnut and it was 2 grams. However much your food weighs, write that down. Next, you can take your stiff wire piece that'll hold your food up and you make it so that the walnut or whatever you're using, walnuts do work especially well, stands up on the top. Make sure you have proper ventilation for this stuff as there will be smoke. Next, you're going to measure out 100 milliliters of water and pour it into the top can of your calorimeter. Pour all of 100 milliliters of water into the top can. Go ahead and set the measuring cup aside. Put the top can inside the tube so that it is suspended. Now measure the temperature of the water and write that down. My water was measured at 19.2 degrees Celsius. This next step should only be performed under adult supervision. I know some of you children out there are probably yelling at me and are angry, but this involves serious flames. Walnuts burn longer than you might think. Also, make sure that you have proper ventilation or that you're doing this outside. Now you can light whatever food you're using on fire. Continue using the torch until the walnut or whatever you're using starts producing flames on its own. Then set the rest of the calorimeter over the flaming food. Continue measuring the temperature of the water intermittently until you stop seeing smoke. The final temperature of my water was 77.2. The final temperature of my water was 77.3 degrees Celsius. I used a pair of hot gloves to lift the calorimeter off of the burnt walnut. This produced quite a bit of heat, so I did need to use these gloves. Using the information we just collected, we can figure out how many calories are in 1 gram of walnut. I'm sitting down with my calculator right now. The first thing we're going to do is calculate the difference between the temperatures of the water. So 19.2 degrees Celsius and 77.3 degrees Celsius. Subtract your lower temperature from your higher temperature. That is the difference between your temperatures. Mine was 58.1 degrees. Now you can multiply this by the amount of water that you had in your top can. In my case, this was 100 milliliters. This is the number of lowercase c calories that were in the food that you burnt. My number was 5,810. The walnut burnt down to about 1 gram. So in the 1 gram of walnut I got, my math says there are 5,810 lowercase c calories. This is 5.81 normal calories that we use for food. My nutrition information says it's about 6 2/3, so it's not 100% accurate. The calorimeter that I made should not be used for scientific purposes, but it gives me about the ballpark. In summary, the formula is your difference between your original food weight and your secondary food weight after it has burned. Multiply the difference in temperature of the water by the amount of water that you had. So multiply your water temperature difference by 100 if you use 100 milliliters of water. Then divide that by 1000, then divide that by the number of grams that burnt away. That's the number of calories in 1 gram of your food. After you're done with walnuts, try goldfish, try peanuts, try other things. Comment about your results in the comments below. So thanks for watching today's video. I hope you enjoyed making a calorimeter and learning how our body uses calories to turn into other things, including energy to move ourselves around. If you want to, hit subscribe and then comment down below about it and I'll reply to your comment. If you've already subscribed, share it with people that you think might enjoy this experiment. Then you can comment about it and I'll reply to you as well. Also, if you don't want to do either of these things, you can still comment about how your calorimeter worked out. Mine worked very well. I would be interested to hear your stories. That's all I've got for you for today, but until next time, thanks for watching.